Welcome friends, today we will learn about fiber optics. So fiber optics, we will learn about only fiber optics in engineering syllabus. So first of all we will learn about definition. What is definition of optic fibers? That is the thin cylindrical structure, pipe-like structure which is made by dielectric material. So definition is thin cylindrical pipe-like structure which is made by dielectric material and which give the path to light to travel through it, and that is based on principle total internal reflection. So that is the definition. So thin cylindrical pipe-like structure made by dielectric material which give the path to light to travel through it, and which based on principle total internal reflection. So difficult words I will tell you, that is the meaning. That is cylindrical pipe structure made by dielectric material, so that is difficult word. Which give the path to light to travel through it, and which based on principle total internal reflection. So that two words I will tell you. First of all, dielectric material means that is glass or plastic only, and I will tell you about total internal reflection. But before that, we will learn about the internal structure of optics. So that is pipe-like structure. So we will learn about what is inside it. So consider it is perpendicular to that screen, and that is inside first, that is core, around is cladding, and last is covering is there. That is like that structure. So core is main part, around is cladding and covering. For covering, two words are there: sheath. We will call covering also sheath or buffer. That is protective covering, protective sheath, or protective buffer also we can call that. So about that, core is 8.5 to 62.5 micrometer. Cladding is 125 micrometer, and covering sheath or buffer is, that is last covering is, that means this is diameter. I will tell you, diameter is at 8.5 to 62.5. Cladding diameter is 125 micrometer, and covering diameter is 250 micrometer. This is general case. And now in which actual traveling up light through optic fibers, that is through core, around it cladding is there. That is remember that always refractive index of cladding is always low than refractive index of core. That you want to remember. And now we will learn about this word, that is total internal reflection. So if you student know that many more things we call that denser or rarer, which is based on refractive index. What is refractive index? That is based on actual arrangement of any material atoms inside it. That is in solid we know that atoms are joined together. In liquid, that is smoothly free, and in air that is very highly movable. So that is a rarer medium, that is lessly denser, and this is mostly denser. So this is shows that denser and rarer material, how we can understand. Now if we take a light and pass a denser medium to rarer medium, then if we consider that two mediums and this is perpendicular, we call that normal. And when we pass that light from denser medium, we think that light goes like that way, because we know that light goes always in straight direction. But due to this medium refractive index change, that light bends away from the normal. That is, actual path of light is like that. And if we consider the light when comes to rarer to denser, that is not that like path light have, which comes towards the normal. That is the condition. When light goes from denser to rarer, light bends away from normal. That is, denser to rarer, away from normal. And when light goes from rarer to denser towards the normal. This box, in all the information, this box and this box, you want to remember always, because this is extra knowledge that you want to know about that. So actual total internal reflection in engineering, I will tell you now. So that is, we learn that when light goes from denser to rarer, so light goes away from normal. So that is condition we will go. So rarer, we will take a denser medium like glass, and rarer is air. That is, refractive index is mu2 and his refractive index is mu1. So when light goes from denser to rarer, we know that light goes away from normal. So this is that is angle of incidence, and this is r, that is angle from incident ray and normal, and refractive angle is normal and refractive ray. So when we increase that I, r also increase. When I increase, then r also increase. If you again I increase, there will be one condition. When r angle, that is refractive angle, becomes 90, that time I becomes QC, that is critical angle. We call that critical angle. And condition is, when we increase the incident angle then greater than critical angle, then R totally reflected in that of medium instead of next medium, that is total internal reflection. And on that this fiber optics works. Okay, thank you students. If you understand that and any doubt is there to in this chapter, so give me information in my comment, and like and subscribe to my channel.